Welcome back to Darwin's School of Hard Sums, the programme that pits me using brains against my fellow comic using brawn. In this case, it's Alex Horn, in a battle to find out which method is best for solving the maths problems modern life throws at us all. Hey, how are you? I'm Darwin. We've been wrestling with a perplexing problem the market has set, so let's see if we're making any progress. So once again, this problem is about 4 diva-like cows who won't get their hooves dirty and walk on grass to get between different cattle sheds. And a poor, poor farmer who has to lay a path to connect them all up. He doesn't want to spend a fortune on the project, so what's the shortest path the farmer can lay? You happy with that?
I'm very happy, Dara. I think I stumbled across the right answer.
And how many tiles did you end up dropping for this?
1.
1?
Yeah. So it's 1 better than a straight cross.
If you actually put it in and do all the trigonometry on it, right, basically you get a total length which is √3 plus 1. Now the question is that less than 2 √2? And you'd have to work that out, and I don't know it off the top of my head because I'm not that kind of person. Marcus, is that less?
Absolutely right. This solution is just slightly shorter. As you found, you managed to save 1 tile. So if you calculate 2 √2, it is 2.828.
2.828. And how much is this?
√3 plus 1 is 2.732.
It's hardly worth the effort.
Yeah, I was thinking that.
1 tile.
I was thinking I'd probably put it down there anyway.
Yeah.
It's nice to have a tile sometimes.
However, you know how I got this? I saw him doing it. And the fact that I've got a really shiny board and I was able to write numbers about it doesn't mean I got it quicker than him. That worked.
So this is scientific collaboration because he had the great idea and you did the calculation.
The technical term is theft.
There's actually a really beautiful way to solve this, which is using bubbles, because bubbles are rather lazy. Like nature's very lazy, tries to find the most efficient solution. So I've got some soap film here, some soap.
This is proper bubble mixer stuff,
yeah.
isn't it?
Here's a copy of our field, and here are the cow sheds. And when I put this in the bubble mixture, the soap film is going to find for me the shortest path, because bubbles are incredibly lazy. So let's put this in and see whether you are right. Okay, pull this out. Okay, do a little...
Wow, that's amazing.
There we go. Isn't that a thing of beauty?
That is gorgeous.
The best thing I've ever seen.
That is genuinely stunning.
And what the rules of bubbles are that bubbles meet 3 at each point at a 120-degree angle. If I put another one on here, what shape would you get? You get a hexagon.
Yeah.
And hexagons, this is the reason you see so many hexagons in nature. Things like the honeycomb. Have you ever been to the Giant's Causeway?
Yeah.
It's full of hexagons.
Stonehenge?
Not so much Stonehenge.
No, because that isn't a natural... that wasn't formed by nature, funnily enough. And look, if you only had 3 cow sheds, do you want to see the shape it would make?
Yeah.
Okay, let's pop one of the roots. Again, it's finding the most efficient way to connect them. That 120-degree angle appearing there. But actually, it's still satisfying the same rules, which were discovered by Plato, who was in fact blind when he discovered it. So you got
Plato.
Plato. No, not Plato. Not Plato.
Oh, sorry, not Plato. We thought you'd mispronounced Plato during all that. Jenny's in there going, he's lost it, this guy.
We thought he was quite clever, but you know.
Plato. Oh, right, who's Plato? And why was he...
Yeah, well, he wanted to understand the rules of how bubbles connect together.
That's very, very good. It was very, very impressive.
What if there was a hole in the middle of the field, like a donut? Would that make it easier?
Wow.
I think we're getting to him. I think we're getting to him. He's coming to the dark side.
Now, what's our big problem?